let's continue with our exhibition of numbers as we know them since elementary school. Okay, so this is again the number line. It's one long ruler with 1, 2, 3, 4, and it goes both ways. Okay, it's a very long line. It never ends. It has all these numbers in between the markers. The markers are 1, 2, 3, 0, minus 1. For instance, there's 1 over 2. That's right in the middle between these three. Between these two. 1 over 2. Sometimes people write this as 0 and then a dot or a comma, depending whether you're Dutch or not. So I'll put a dot, 0.5. Now that's also 0.50. Okay, so what does this mean? This means that this is 0 times 1 plus 5 times 1 over 10. And if I write this, I say that it's equal to the same thing plus 0 times 1 over 10 squared. Just like 9 over 10 is 0.9. And 99 over 100 is 90 plus 9 is 90 over 100 plus 9 over 100. You divide by 10 on numerator and denominator, so this is 9 over 10 plus 9 over 100. So that's 0.99. That's somewhere here. I can go on like that. It's 9 over 10 plus 9 over 100, 9 squared plus 9 over 10 cubed. So that's 0.99. That's over here, very close to 1. Okay, so 0.99 is another number. Another number, etc. So do we also have to point 0.9999, where this is a never-ending sequence of 9s? Yeah, so we have a sequence of numbers, 0.9, the next one is 0.99, the next one is 0.99, etc. A sequence of numbers. Okay, this goes on forever. And after forever, or at forever, we have 0.9999, that never-ending sequence of 9s. Okay, if we draw these numbers here, then we can ask ourselves what this number might be. Okay, so which is this number equal to a number that we already know? 0 point, a never-ending sequence of 9s. Okay, so we can come to the conclusion that this should be equal to 1. Or we can come to the agreement that we should consider this as being equal to 1. Okay, that's a consideration. If we come to the agreement that this is equal to 1, then this statement here, that this is equal to 1, in modern notation is saying that the sum of 9 over 10 to the n, where I sum n from 1 to infinity, that this is equal to 1. So this is a sum with infinitely many terms. I take the first one, n is 1, 9 over 10. Then the second one, 9 over 10 squared. The third one, etc. And I add and add and add. I keep adding forever. Okay, so then this statement here in mathematical terms is saying that this sum is equal to 1. And if you like, you can think of this notation as saying that first n is 1, then n is 2, then n is 3. I could also write more fancy notation, 9 over 10 to the n, and say that this is also equal to 1. Here I've lost my direction, so to speak. We just take every n in the natural numbers, we compute 9 over 10 to the n, and we add all that. Okay, that's a slightly different perspective than what I explained here. Okay, so in mathematics it's clear that we want to have statements of this kind. Okay, but these are just reformulations of what we've written here. That 1 is 0.9999. Just like this 1 over 2 here is also equal to 0.4999, etc. Yeah, so we can come to the agreement that these decimal expansions, which never end, that these are that these reproduce our simple fractions. Okay, that's very nice. And that's fractions that have decimal expansions. But these decimal expansions depend on the fact that we happen to count with 10 fingers. And therefore we have 10 as the special number, such that we have 1. Okay, so that's, this number line goes on forever. Okay, so let's draw another piece. At some point we have here 9, 8, and then here we have 10, and here we have 11. Now if we would have been born with 6 fingers on each hand, then this would not be 2 separate symbols. This would be, I don't know, something that corresponds to 10. Let's think of a number that it could in a symbol. It could be this symbol. Yeah, so this is 10. And then here we could have another symbol, delta. we could say that delta is the symbol for 11. And then here at 12, yeah, we would have had 12 fingers. So then here we would write 1, 0. And somewhere over there we would have 22. What would 22 be? 22 would be a 1, and then with the 0 here replaced by this epsilon. And 23 would be 1 with the 0 replaced by delta. Okay, so our number line comes with a choice. Our representations of our natural numbers come with a representation that comes from our fingers. And this fantastic invention to start using the exponents of 10, this is not 10, this is 12, to start using the exponents of 10 to represent this delta here as 10 plus 1, and to represent 101 as 10 squared plus 1, etc. That is something that is a very nice way to calculate with numbers. The representation based on the powers of 10. The powers of the power of 10. The powers of the positive powers of 10. And these are negative powers of 10. Yeah, because we write 9 over 10 and 9 over 100. We write as, where is it? 9 over 10. 9 over 10. This is 9 times 10 to the minus 1. Yeah, 10 to the minus 1 is 1 over 10. This is the way we count with numbers, with the positive integers. And but there are other fractions which do not have these finite representations if we use base 10. 2 over 3 is 2 over 3 here. Okay, this 2 over 3 is causing a bit of a pain for people who want to say what we have to do in education, and they don't like the pain. So they put this equal to 0.6. Now this equality occurs in documents written after a request of our government and accepted for being correct by our same government. Okay, so SLO is an institution in the Netherlands that has a say in the development of curricula, and they came with this equality. And there's also 1 over 3. It's not so clear. Yeah, if 2 over 3 is 0.66, then 1 over 3 is of course 0.33. Yeah, so these are equalities that children are inclined to learn if they have teachers that follow the guidelines by this institute, SLO. In Dutch de Stichting voor Leerplanontwikkeling. Yeah, so that's a bit of a problem in the Netherlands. Okay, so there's much more to be said about these. Of course, this is complete nonsense. It's not equal. not equalities. Yeah, so calculations with 1 over 3 as a fraction hardly occur in the official pieces. 1 over 3 has become a name, so for a number, but calculations with these numbers are avoided, which is a bit of a, yeah, it's very sad. Okay, so these are our number, this is again our line with all the numbers and things we want to do with that. So let's remember a couple of things. So I'll erase the black part of the blackboard and write down what we remember from these considerations.